Greetings, my name is Faisal. I'd like to introduce you to a concept I call duality. Duality is the ability of backdoored DLLs to keep one implant alive at all times. Infected DLLs also have the ability to reinfect each other through program updates. In this video, I'll demonstrate this capability and its respective tooling through the use of a DLL backdooring pipeline coded in C#, a shellcode compilation methodology, and a C2 helper script. It is possible to backdoor DLLs on the fly during an operation. The end result allows for longer-term persistence even through program updates. During advanced engagements, it may become necessary to obtain longer-term access to high-value targets. Extracting sensitive information over time, such as files, is of interest. Techniques such as auto-start programs, registry keys, or scheduled tasks are under high scrutiny. Swapping out DLLs for execution has been feasible. Duality takes this to the next level. After obtaining file system access to a target, either through a lesser implant or internally via SMB, it is possible to simply swap out DLLs while programs are running. Let's walk through a demonstration of these pipelines in action. In this case, initial access has been provided through a Cobalt Strike beacon. First, we execute our custom Cobalt Strike aggressor command, Duality. Then we select which listener's shellcode we're interested in using for this capability. Afterwards, we choose from a set of DLLs that are susceptible to being backdoored. Note that no intrusive actions happen on the target machine beyond file discovery. Once selected, the rest is automated. First, the target DLLs are downloaded to the C2 server. Then, they're synchronized to the local machine. The DLLs are then ingested by the C# shellcode compiler. This uses a program written in C that is customizable by the operator. Duality's core logic exists in this file. Each DLL will contain this logic prior to execution handoff back to the DLL. This code will check for the infected state of each dual. If infected, the program is backed up. If uninfected, the program is restored from that backup location. Finally, we perform process injection using dynamically resolved Windows API calls. This is performed surgically with certain Windows DLL loading guidelines in mind to avoid the DLL crashing during runtime. Windows API calls are resolved from a packed and encrypted clean empty DLL section to avoid EDR hooks during execution. After injection is complete, control is relinquished back to the DLL's main functionality. Let's examine this in action. We run any backdoor program, thereby establishing all backups. Then we will simulate a program update by restoring the directory to its original state. By running any other backdoor programs, regardless of any program's running state, we can see that the infection is restored. Duality is back in play. Ultimately, Duality enables a capable operator to craft custom logic to be instilled in any DLLs susceptible to Duality's current capabilities. I hope that by publishing this technique, allowing for the automation of long-term persistence, developers will consider taking file signatures more seriously prior to load events.